Hello students. So today I am doing class 12 science. The subject is mathematics. The topic is inverse circular function, right? So in the last class also we were doing the same topic, that is inverse circular function. So this is the continuation class, right? So let's do from question number 13, that is exercise for 4 marks section. This is of section 4 marks, okay? And page number is 97. So let us prove this question number 13. So now question number 13 is you have to prove tan inverse x minus tan inverse y in terms of sine inverse. That is, in terms of sine inverse, it is sine inverse x minus y whole divided by within square root. There are two factors, that is 1 plus x square into 1 plus y square, right? So let us prove it. So LHS is equal to, you write down LHS is equal to tan inverse x minus tan inverse y, right? So you can use the formula here in this case also. What is that formula that you can use here? Which is equal to tan inverse. What is the formula for tan inverse x minus tan inverse y? It is tan inverse x minus y upon 1 plus xy. You know this formula. If there is minus sign, you should write minus sign in the numerator and plus sign in the denominator, right? So now, what will you do? You have to convert this tan inverse into sine inverse. I already told you that whenever you have an inverse circular function, you can convert that inverse circular function into any other inverse circular functions. That means you can convert this tan inverse into sine inverse, cosec inverse, cos inverse, sec inverse, cot inverse, right? So, but in this case, you have to convert this tan inverse into sine inverse, right? So let us assume this inverse circular function as theta, right? So let us write, let tan inverse x minus y upon 1 plus xy is equal to theta. So when tan inverse changes its sides, it becomes tan on the right hand side, isn't it? That means tan theta is equal to x minus y divided by 1 plus xy. Is that clear? So if tan theta is equal to x minus y upon 1 plus xy, now we have to get the value for sine theta in order to prove sine inverse, isn't it? Now in class 10, you did the problem like, if tan theta is given, you can easily get the value of sine theta using perpendicular base hypotenuse formula. You can use that formula here also, okay? If tan theta is equal to x minus y upon 1 plus xy, how can you get the value for sine theta? Let us use the method that you have done in class 10, okay? So from tan theta, you have to get the value for what? Sine theta in order to prove it in terms of sine inverse, right? So now we know that what tan theta is equal to p by v. Some people have curly brown hair turned permanently black. That is sin theta is equal to p by h, cos theta is equal to p by h, and tan theta is equal to p by v. You know that, isn't it? So, but tan theta is equal to p by b. You know, perpendicular by base. So this left hand side are equal. Right hand sides must be equal, right? So p by b is equal to x minus y upon 1 plus xy. Now in this case, you can equate x minus y with p. That is, p is equal to x minus y. B is equal to what? 1 plus xy. Now we need the value for hypotenuse, that is h. You know Pythagoras theorem, h square is equal to p square plus b square. You know that, isn't it? So what is the value for h in this case? It is h is equal to root over p square plus b square. So you know the method. How did we get this h is equal to root over p square plus b square? This is known as what? Pythagoras theorem, right? So therefore h is equal to root over, now let us put the value for p. What is the value for p here? X minus y whole square plus, what is b whole square? This is 1 plus xy whole square, right? So now let us simplify it. Therefore h is equal to root over, now it is Now this is the form a minus b whole square. You know the formula a minus b whole square, isn't it? A square minus 2ab plus b square. Okay, sir? So what is the formula in this case? Instead of a there is x, instead of b there is y. So it is x square minus 2xy plus y square, right? Plus. Now in between these two terms there is plus sign. So what is 1 plus xy whole square now? This is again a plus b whole square. What is a plus b whole square? A square plus 2ab plus b whole square, right? What is a whole square here? 1 plus, what is twice ab? 2 into 1 into xy, that is 2xy. Then plus, what is b whole square in this case? It is xy whole square, isn't it? That means x square, y square, right? So here you can cancel minus 2xy plus 2xy. So what are the remaining terms here? It is x square plus y square plus 1 plus x square y square. There are 4 terms there. These 4 terms can be factorized now. Okay? So how do you factorize it? Root over, you have to take the term in pair. Let's write 1 first. 1 plus, then write down x square. Right? Then comes, you write plus y square plus x square y square. So that you can easily factorize it. Okay? So, or h is equal to root over. Now, from the first 2 terms, what is common there? There is only one common. So, it is 1 within bracket 1 plus x square plus, in between these 2 terms, from the next 2 terms, what is common there? Y square, isn't it? Y square within bracket 1 plus x square, right? Or h is equal to root over, what's common here? It is 1 plus x square into 1 plus y square. So we get the value for h as root on the 1 plus x square into 1 plus y square. So this is the value for h. But in this case, you have to get the value for sine theta, isn't it? Therefore, sine theta is equal to p upon h. Some people have sine theta is equal to p upon h, right? So now, therefore sine theta is equal to, some people have sine theta is equal to p by h. What is the value of p? X minus y. So you can write here x minus y divided by, what is the value for h? This is the value for h. That is root under 1 plus x square plus 1 plus y square, right? Now let us get the value for theta. That means you have to take sine to the right hand side, isn't it? So theta is equal to, what is theta now? Therefore theta is equal to sine inverse x minus y divided by root under, it is 1 plus x square into 1 plus y square. Is that clear to all of you? So we have got the value for theta. So now, actually we had from the left hand side, LHS is equal to, what was LHS actually? We had simplified tan inverse x minus tan inverse y, isn't it? We had simplified tan inverse x minus y upon 1 plus xy, right? Tan inverse x, actually we had simplified tan inverse x minus tan inverse y. So it was, left hand side is equal to tan inverse, it was x minus y upon 1 plus xy, right? So which is equal to theta was assumed. This inverse circular function was assumed as theta. Now what is the value of theta? It is sine inverse. So this tan inverse and this sine inverse are equal, right? So which is equal to sine inverse, this is x minus y divided by, it is root over what? It is 1 plus x square into 1 plus y square. So we got the left hand side, which is equal to tan inverse x minus y upon 1 plus xy, that was simplified. Left hand side was simplified, and this was assumed as theta. And what is the value of theta here? It is sine inverse x minus y upon root under 1 plus x square into 1 plus y square. So which is equal to right hand side. So it is proved. So I think you have understood it. Okay, so you can copy it. We'll do the next problem now. Now we will do the next question, that is you have to prove this question number 14. This is also proof that sin inverse x now number 14 is also proof that sin inverse x plus sin inverse y in terms of cos inverse, that is cos inverse within second bracket, again within square root. There are two factors, 1 minus x square into 1 minus y square, then minus xy. Okay, so now let us prove it. So LHS is equal to sin inverse x plus sin inverse y. So how will you prove it? Don't use the formula directly here. If you use the formula directly here, it will be complicated to convert it into cos inverse, isn't it? So what we will do here is SI मा हामी के गर्छौं, यसलाई नै cos inverse मा चेन्ज गरिहाल्छौं. Let us convert this sin inverse x into cos inverse x. You know how to convert it, isn't it? So now let sin inverse x is equal to theta, right? So or x is equal to what? This is sin theta. Sin inverse, when it goes to the right hand side, it becomes sin, right? Or you may write sin theta is equal to x. That means we get the value for sin theta, which is equal to x. Now from sin theta is equal to x, you can get the value for cos theta in terms of x, isn't it? So you know this formula, that is cos theta is equal to root under 1 minus sin square theta, isn't it? So since you know that cos theta is equal to root under 1 minus sin square theta, there is a formula, right? So or cos theta is equal to root over 1 minus, what is sin square theta? It is x square, right? So what is the value of theta now? That is theta is equal to, now if cos changes its sides, that means when it goes to the right hand side, it becomes cos inverse. So theta is equal to cos inverse root over 1 minus x square, right? So now we had assumed this sin inverse x is equal to theta, and now what is theta? So theta equals what? Cos inverse root under 1 minus x square. That means you can equate the sin inverse x with cos inverse root under 1 minus x square, right? So therefore we have sin inverse x is equal to cos inverse root over 1 minus x square. So if you know this relation, you can directly write down, instead of sin inverse x, we can directly write down cos inverse root over 1 minus x square. Is that clear to all of you? Similarly, what is sin inverse y? So instead of x, you can write y, isn't it? So therefore, similarly, sin inverse y is equal to, what is it? Cos inverse root over 1 minus y square. So as a formula also, you should know that sin inverse x in terms of cos inverse is cos inverse root over 1 minus x square. Or sin inverse y is equal to, in terms of cos inverse, it is cos inverse root over 1 minus y square. Is that clear? So let us write down here. What is sin inverse x? It is cos inverse root over 1 minus x square plus, what is sin inverse y? It is cos inverse root over 1 minus y square, right? Now you can easily prove this right hand side now, because both these terms are converted into cos inverse. That is, what is sin inverse x in terms of cos inverse? It is cos inverse root under 1 minus x square. And what is sin inverse y in terms of cos inverse? It is cos inverse root over 1 minus y square. So is that clear to all of you? So now, which formula is used? Cos inverse x plus cos inverse y. Now you should know the formula. What is cos inverse x plus cos inverse y now? What is it? Cos inverse x plus cos inverse y is equal to, what is the formula that you can use here? It is cos inverse within second bracket. First of all, it is xy. Then if there is plus sign, you have to write minus sign, right? Then within square root, what do we get? 1 minus x square into 1 minus y square. So this is the formula that you can use here. So instead of x, there is root under 1 minus x square. Instead of y, there is root under 1 minus y square. So use that formula now, right? So let us use the formula here. Is equal to cos inverse. Now write it within third bracket. Okay. What is x into y here? Actually there is xy. X is this one and y is that one. Right. So root over 1 minus x square into root over 1 minus y square. Okay. Then you should write minus sign. Minus sign, then again within square root. Then again within square root, there is 1 minus x square. Write it within second bracket. 1 minus, what is x whole square in this case? It is root over 1 minus x square is x. This is whole square. That is root over 1 minus x square whole square, right? Is that clear? Actually it is 1 minus x square. 1 is kept fixed here. Minus what is x in this case? It is root over 1 minus x square. That's why you should write here root over 1 minus x square whole square. Second bracket is closed. Similarly, what is the next factor? It is 1 minus y square. But what is y here? It is root under 1 minus y square. This whole thing is what? Y. So 1 minus, what is y whole square? In this case, it is root under 1 minus y square whole square. Second bracket is closed. Then also third bracket is closed. Is it understood? So it is xy, this is x and this is y, minus root over 1 minus x square means root over 1 minus what is x whole square in this case? Root over 1 minus x square whole square, right? Into what is 1 minus y square in this case? It is 1 is kept fixed minus what is y whole square? Root over 1 minus y square whole square. Okay? Second bracket is closed, then third bracket is also closed. Understood? So that means in this case, x is root under 1 minus x square and y is root under 1 minus y square. Right? So now let us simplify it again. Is equal to cos inverse within third bracket. You can write it within square root. That is 1 minus x square into 1 minus y square. That means both the expression on the square root are kept under 1 square root. Okay, that is root over 1 minus x square into 1 minus y square. Next, minus root over, now this is within second bracket 1 minus, what is root over 1 minus x square whole square? What is root over 1 minus x square whole square? Square root will be removed. You will get 1 minus x square, isn't it? Then you have to multiply by minus sign. Minus 1, minus 2 minus plus x square. Right? Similarly, next factor. Within second bracket, 1 minus, again this one, root over 1 minus y square whole square is, square root will be removed. You will get 1 minus y square. But because of this minus sign changes, minus 1, minus 2 minus plus y square. So here second bracket is closed. Then also third bracket is closed. Is it clear now? So now let us write down the next step. So what is the next step now? Which is equal to cos inverse within third bracket root over, it is 1 minus x square into 1 minus y square, right? Minus root over, now here 1 gets cancelled, you get only x square into, here also 1 gets cancelled, you get only y square, right? So here third bracket is closed. Now next, you can get the square root of x square y square, isn't it? Is equal to cos inverse. Now you may write second bracket as in the question. And within root we have here 1 minus x square into 1 minus y square. Is it clear? ठीक छ यहाँसम्म? अनि minus, what is square root of x square y square? So it is x into y. So it is x into y. Second bracket is closed. So which is equal to what? Right hand side. So it is proved. Understood? So we can copy it. We'll do the next question now. So now we will do question number 17. So you have to prove this result. Okay? LHS is equal to RHS. What is left hand side here? Tan inverse x minus y upon 1 plus xy plus, what is the second term? Tan inverse y minus z upon 1 plus yz plus tan inverse z minus x upon 1 plus zx is equal to what? tan inverse x square minus y square upon 1 plus x square y square plus tan inverse y square minus z square divided by 1 plus y square z square plus tan inverse z square minus x square upon 1 plus z square x square. So let us prove this LHS is equal to RHS. So now in this case, let us find out the value for left hand side first. So let us write down this left hand side. Okay, that is tan inverse, same expression is here, that is left hand side. Okay, so in this case, which formula is used? Now you know the formula, you should know the formula in this case also. Now in this case, which formula is used? Now you know this formula, that is tan inverse. It is x minus y upon 1 plus xy, right? Tan inverse in the numerator x minus y divided by in the denominator x 1 plus xy, right? So which formula is used here? Which is equal to tan inverse x. If there is minus sign in the numerator, you should write minus. That is minus, this is tan inverse y. So you should use this formula. Similarly, in this case also, tan inverse y minus z upon 1 plus yz. You can use the same formula in this case also. And in the third term also, you can use this same formula. Okay. So is equal to, what is the formula directly here? It is tan inverse x minus tan inverse y plus, this is, instead of x there is y, instead of y there is z. So what is the formula? It is tan inverse y minus tan inverse z plus, next, instead of x there is z and instead of y there is x here. So what is the formula here again? Tan inverse, first of all, what is x here? Z minus tan inverse, what is y here? This is x. Is that clear to all of you? So tan inverse z minus x upon 1 plus zx, is formula is tan inverse z minus tan inverse x, right? So we can cancel here. This plus tan inverse x minus tan inverse x gets cancels. Then minus tan inverse y plus tan inverse y gets cancels. Minus tan inverse z plus tan inverse z also gets cancels, which is equal to 0. So this is your left hand side. So you have understood? Thus similarly, you have to get the value of the right hand side. So right hand side should also be 0, right? So let us find out the value for right hand side. So you can copy it. I think you have copied it. Okay. So now let us write down this right hand side. So what is RHS now? What is RHS here? Tan inverse x square minus y square upon 1 plus x square y square plus, next, what is the second term here? Tan inverse y square minus z square upon 1 plus y square z square plus, what is the third term out here? It is tan inverse z square minus x square upon 1 plus x square y square, right? So now again here also you can use the same formula. Instead of x there is x square, instead of y there is y square. This is instead of x there is x square, instead of y there is y square. Same formula can be used. That is tan inverse x minus y upon 1 plus xy is equal to tan inverse x minus tan inverse y, right? So let us use this formula, is equal to tan inverse x square minus tan inverse y square, right? Instead of x there is x square, instead of y there is y square. Similarly, plus in this case also, instead of x there is y square, instead of y there is z square. So same formula is used, that is tan inverse y square minus tan inverse z square plus, next again, what is the value for x here? Z square. What is the value for y here? It is x square. So same formula is used again, that is tan inverse z square minus tan inverse x square. Is that clear? So now here you can cancel the similar terms, plus minus sign. First and last term gets cancels, plus minus, then second and third, and then fourth and fifth, which is equal to 0. So left hand side was also 0, right hand side is also 0. That means we have proved LHS is equal to RHS. Therefore, LHS is equal to RHS. Proved. Is it understood? Now we can copy it. We'll do the next one. So now we will do the next question. Prove that again. This is question number 18. So this question is very important. Okay. So you have to prove cos inverse x is equal to 2 sin inverse within square root 1 minus x upon 2. Again is equal to 2 cos inverse within root 1 plus x by 2. Again is equal to 2 tan inverse within square root 1 minus x square whole divided by 1 plus x. Okay. So first of all, let us prove this first is equal to second. Okay. Let us prove to prove that is first. That means cos inverse x is equal to 2 sin inverse within square root 1 minus x whole divided by 2. Right. Let us prove this first part first. That is first is equal to second. So in this case we can do the trigonometric substitution method. We can prove it from right hand side. Okay. So let us write down RHS is equal to 2 sin inverse within square root 1 minus x by 2. So let us do the trigonometric substitution method. So what should you put for x? हामीले यहाँ x को भ्यालुमा trigonometric substitution गर्नु पर्यो. The x is equal to which trigonometric substitution should be done here in order to get sin inverse sin theta form. So that if sin inverse sin theta is there, you can write theta. Then you can easily prove this right hand side, which is equal to cos inverse x. Okay. Since there is cos inverse x on the left hand side, so you put x is equal to what? Cos theta. Okay. So let us use x is equal to cos theta. So let x is equal to, what should you put here? X is equal to cos theta. Let us get the value for theta here. What is the value for theta? So it is cos inverse x. Is that clear? So now what is right hand side now? So RHS is equal to 2 sin inverse. Then within square root 1 minus, what is the value for x here? It is cos theta, this whole divided by 2. Is it clear to all of you? So now let's simplify it again, which is equal to 2 sin inverse, then within square root. Now can you tell me what is the formula for 1 minus cos theta? What is 1 minus cos theta formula from submultiple angle? This formula is from submultiple angle, right? That is 1 minus cos theta is equal to 2 sin square theta by 2. Okay? This is the formula from the trigonometry. The chapter is submultiple angle. You should know it, right? So what is 1 minus cos theta? It is 2 sin square theta by 2 whole divided by 2 is already there. So write down 2. So 2 gets cancels. Is equal to 2 sin inverse. Now what is the square root of sin square theta by 2? It is sin theta by 2 only. Sin theta by 2, which is equal to, now by formula, what is sin inverse sin theta by 2? It is only theta by 2. So it is 2 into theta by 2. Here 2 gets cancels, which is equal to theta, right? So now, what will you write for theta? We have got here theta is equal to cos inverse x. So theta is equal to what? This is cos inverse x. So we have proved that cos inverse x is equal to 2 sin inverse root under 1 minus x by 2. That is RHS is equal to LHS. So we have done it. Is that clear? Similarly, you can prove first is equal to third. Right? So let us prove it now. So we have understood. Now let us prove now you will prove first is equal to third, right? So cos inverse x is equal to 2 cos inverse within square root 1 plus x whole divided by 2. So in this case also prove it from right hand side. Okay. So now RHS is equal to 2 cos inverse within square root 1 plus x whole divided by 2. Right? So now here also you should do the trigonometric substitution method. The trigonometric substitution method should be done out here to make it more easier. Right? So 1 plus x is there. So what will you put for x? Since you have to prove cos inverse x, here also you put x is equal to cos theta. this will be 1 plus cos theta. So you know the formula from submultiple angle again. What is 1 plus cos theta? 1 plus cos theta will be equal to what? 2 cos square theta by 2. Is it clear? So 1 plus cos theta को formula के रहेछ? It is 2 cos square theta by 2. ठीक छ? So let us put x is equal to cos theta again. That is, trigonometric substitution is done here, right? So let x is equal to cos theta, right? So what is the value of theta here? It is cos inverse x. Now this RHS now becomes RHS is equal to 2 cos inverse within square root. It is 1 plus, what is x here? 1 plus cos theta, this whole divided by 2. Is that clear? Now next. Now you know the formula of 1 plus cos theta. 1 plus cos theta is equal to 2 cos square theta by 2 from submultiple angle, isn't it? So which is equal to, this is 2 cos inverse within square root. What is 1 plus cos theta? It is 2 cos square theta by 2 whole divided by 2. Is that understood? 1 plus cos theta is equal to 2 cos square theta by 2. We have written out here this whole divided by 2. Is that clear? So here 2 gets cancels, right? So it's equal to 2 cos inverse. Now, what is within square root cos square theta by 2? What is the square root of cos square theta by 2? It is cos theta by 2. Is that clear? So which is equal to 2 into theta by 2. Okay? So here 2 gets cancels, which is equal to theta. Again, you can put the value for theta. What is the value for theta? It is cos inverse x. So we have proved it. Okay? So we have proved this first is equal to third. Right? So you can copy it. Again, what is to be proved? This first is equal to fourth. Right? Now, to prove cos inverse x is equal to 2 tan inverse within root 1 minus x square divided by 1 plus x. Now let us prove this result. That is, first is equal to fourth. So here also let us prove it from the right hand side. That is, RHS is equal to, what is RHS here? 2 tan inverse within root 1 minus x square divided by 1 plus x. Okay? So now how can you do this problem? Here also you should do the trigonometric substitution method. So what should you put for x? So within square root there is 1 minus x square. Within root there is 1 minus x square. Okay? So if within square root there is 1 minus x square, what should you put for x? Either you can put x is equal to sine theta, or you may put y is equal to cos theta. Is that clear? So if you put x is equal to sine theta, root over 1 minus sine square theta will be there, whose formula is cos theta. If you put y is equal to cos theta, within square root there will be 1 minus cos square theta, and its formula is sine theta. You know that, isn't it? But in this case, what should you put for x? Is it sine theta or cos theta? So on the left hand side there is cos inverse x. Since you have to prove cos inverse x, that's why you have to put x is equal to cos theta. Since you have to prove cos inverse x, you put x is equal to what? Cos theta. So let x is equal to cos theta. Yadi near sine inverse hoga, we could have put x is equal to sine theta. Since you have to prove in terms of cos inverse, that's why we are substituting x is equal to cos theta, right? So now what is theta is equal to? This is cos inverse x. Is that clear? Now RHS. Now RHS is equal to 2 tan inverse within square root 1 minus cos square theta divided by 1 plus cos theta. Okay? So instead of x, we are putting x is equal to cos theta. Now let us simplify it once again. Okay. So let us simplify it. So right hand side is equal to 2 tan inverse. So let us write it within first bracket. Now what is the formula for root over 1 minus cos square theta? You know from class 10, isn't it? Actually 1 minus cos square theta is sin square theta. And what is square root? It is sin theta. Sin theta divided by 1 plus cos theta. So now you have to simplify, or you may use the formula of sin theta and 1 plus cos theta in such a way that you should get here tan inverse tan form. Now in this case also you can use the formula from submultiple angle of trigonometry, right? So sin theta is equal to, what is the formula? 2 sin theta by 2 cos theta by 2. This formula is from trigonometry, that is submultiple angle, right? And also you know that 1 plus cos theta is equal to, this is 2 cos square theta by 2. Just now we did this formula, isn't it? For the second part, that is 1 plus cos theta is equal to 2 cos square theta by 2. Is it clear? So let's use this formula here. That is 2 tan inverse within bracket. What is sin theta? It is 2 sin theta by 2 cos theta by 2. 2 sin theta by 2 cos theta by 2 divided by, what is 1 plus cos theta? What is 1 plus cos theta? It is 2 cos square theta by 2. So this is the formula that you can use here. Okay. So here you can cancel. This 2 gets cancels. Cos theta by 2 and square will be cancelled, which is equal to 2 tan inverse. Now within bracket. So what is the formula now? Sin theta by 2 upon cos theta by 2. What is that? That is your tan theta by 2. That is your what? Tan theta by 2. Okay. So is equal to 2 into, again you know this formula. What is tan inverse tan theta by 2? It is theta by 2. So here 2 gets cancels, which is equal to theta. Now what is theta is equal to now here again? It is cos inverse x. So theta is equal to cos inverse x. That is, we have proved this first is equal to last. That is, first is equal to fourth. Is that understood? So so you can copy it. You have to write hence. You have to write hence. So you can copy this question again. Hence cos inverse x is equal to 2 sin inverse root over 1 minus x by 2 is equal to 2 cos inverse root over 1 plus x by 2 is equal to what? Is equal to 2 tan inverse within root 1 minus x square upon 1 plus x. You can put it within first bracket. This is tan inverse. Is it understood now? Hence, we have proved cos inverse x is equal to 2 sin inverse root under 1 minus x by 2 is equal to 2 cos inverse root over 1 plus x by 2 is equal to 2 tan inverse root under 1 minus x square whole divided by 1 plus x. So, proved. Is that clear? So, this question is very, very important. Okay, so I think you have understood it. So, you can revise it at home. So, we'll do the next question now. So now let's prove question number 19. You have to prove that cos of sin inverse x whole square is equal to sin cos inverse x whole square. You have to prove LHS is equal to RHS. So let us write down left hand side. Okay. So LHS is equal to within second bracket cos within bracket sin inverse x whole square. Okay. Now since this is cos, you can convert this sin inverse x into cos inverse. Just now we did some problem in which sin inverse x was converted into cos inverse, isn't it? So you know the formula, directly you can write down. So you can write it as a formula. Sin inverse x is equal, in terms of cos inverse, it is cos inverse root over 1 minus x square, right? So sin inverse x in terms of cos inverse is cos inverse root over 1 minus x square. Is that clear? So now it's equal to cos within bracket. Now this sin inverse x you can convert into cos inverse using that formula. So it is cos inverse root over 1 minus x square, second bracket closed, whole square, right? Which is equal to, what is cos inverse root over 1 minus x square? This cos inverse will be cancelled. Like if there is cos inverse x, you can write only x, but in this case it is cos inverse will be cancelled, and you will write root over 1 minus x square whole square, which is equal to, what is square root? Whole square. Square root will be removed, that is 1 minus x square. So this is your left hand side. Now similarly you can get right hand side now. So what is RHS here now? Sin within bracket cos inverse x, second bracket closed, whole square, right? So in this case also you can convert cos inverse x into sin inverse, because there is sin here. If this is sin, you can convert cos inverse into sin inverse. So what is the formula that you can use here? Cos inverse x is equal to sin inverse root over 1 minus x square. So you can use as a formula in this case also, but you should memorize it. What is cos inverse x in terms of sin inverse? It is sin inverse root over 1 minus x square. Or what is sin inverse x in terms of cos inverse? It is cos inverse root over 1 minus x square, right? So sin inverse x is equal to cos inverse root over 1 minus x square. You can use this two formula here, right? So which is equal to, within second bracket, sin. Now in this case, what is cos inverse x in terms of sin inverse? It is within bracket. So instead of cos inverse x, what will you write? This one, first one, that is sin inverse root over 1 minus x square. So here second bracket is closed, whole square, right? So now this right hand side now becomes, is equal to, within bracket, this sin inverse will be cancelled. You will get only root under, it is root over 1 minus x square whole square, right? So what is square root whole square? Square root will be removed. So which is equal to, it is 1 minus x square. That means LHS was 1 minus x square. Right hand side is also 1 minus x square. That means we have proved LHS is equal to RHS. Therefore, LHS is equal to RHS. So it is done, proved. You have understood? So as a formula you can write it. Okay? That is cos inverse x is equal to sin inverse root over 1 minus x square, and sin inverse x is equal to cos inverse root over 1 minus x square. So this formula is used to prove this result. Okay? That is LHS is equal to RHS. Now we'll do the next question. So now we'll do question number 20. Here also prove that. You prove sin inverse within square root x minus q upon p minus q is equal to cos inverse within square root p minus x upon p minus q is equal to cot inverse within square root p minus x upon x minus q. So let us first prove this first is equal to second. Okay. So now let us prove first is equal to second, right? So therefore first one here is, that is sin inverse root over x minus q upon p minus q. So you have to convert this sin inverse into cos inverse now. Let us assume this is equal to theta. This one is equal to theta. Let sin inverse root over x minus q upon p minus q is equal to theta, right? Now when sin inverse goes to the right hand side, it becomes sin theta. That means you will get the value of sin theta, isn't it? So sin theta is equal to root over x minus q upon p minus q. Is that clear now? So now what will you do in the next step? Since you have to convert this sine inverse into cos inverse, so first of all you have to convert this sine theta into cos theta. You know how to convert sine theta into cos theta, isn't it? Because we know the formula, that is cos theta is equal to root over 1 minus sine square theta. In class 10 we did it, isn't it? That is cos theta is equal to root under 1 minus sine square theta. Let us use the formula here. Therefore cos theta is equal to root over, this is 1 minus sine square theta. Is that clear? So let's use this formula to get the value for cos theta. So therefore cos theta is equal to root over 1 minus, what is sine square theta now? What is the value for sine theta? It is this one, root under, so within bracket root under x minus q upon p minus q whole square, right? That is, we have substituted the value for sine theta. We put the value for sine theta, or we substituted the value for sine theta. Okay, that is. So now, in this case, we have substituted the value for sine theta in that case. Okay. Now let's simplify it. What is square root whole square? Square root will be removed. That is, cos theta is equal to root over 1 minus x minus q upon p minus q. Right? Let us simplify it. Or cos theta is equal to root over, what's the LCM here? P minus q. You know that, isn't it? So p minus q into 1. P minus q minus x. Now here sign changes, minus to minus plus q. Here q gets cancels. So what is cos theta is equal to now root over p minus x upon p minus q. Right? So now what is the value of theta here? Therefore theta is equal to, this is cos inverse within square root p minus x upon p minus q. That is, sine inverse root under x minus q upon p minus q was assumed as theta, and theta is equal to cos inverse root over p minus x upon p minus q. That means we can equate sine inverse root over x minus q upon p minus q with cos inverse root over p minus x upon p minus q. Is that clear to all of you? So now this was sine theta, isn't it? Now we have to prove in terms of cot inverse. That is, you have to prove theta in terms of cot inverse. Okay. So let us mark it as number 1 and let us mark it as number 2. So in order to get the value for cot inverse, first of all you have to get the value for cot theta. So how can you get the value for cot theta from 1 and 2? You have to divide 1 by 2 or 2 by 1. You should divide 2 by 1 to get the value for cot theta, because cot theta is cos theta by sin theta. Now let us write dividing 2 by 1, right? So let us divide 2 by 1. So what do we get? It is cos theta divided by sin theta is equal to, what is cos theta? What is cos theta? It is root over p minus x upon p minus q. This divided by root over what? This divided by root over, it will be x minus q upon p. So now, this is root over p minus x upon p minus q divided by, what was the value for sin theta? In the previous step, the value for sin theta was root over x minus q upon p minus q, right? So now in this case, in the numerator, within square root there is a fraction. You can write down this square root both in the numerator as well as in the denominator. That is, what is cos theta by sin theta? It is cot theta is equal to root over p minus x upon root over p minus q. Here square root are separated. That is, square root is written both in the numerator as well as in the denominator. So now when this denominator goes up in the numerator, it becomes upside down, isn't it? That is root over p minus q upon root over x minus q, right? So here these two gets cancels. So what is cot theta now? So cot theta is equal to root over p minus x upon root over x minus q. Alright? Or what is the value for cot theta? So cot theta is equal to within square root p minus x upon x minus q. Is that clear? So what is the value for theta? So theta is equal to cot inverse within square root p minus x upon x minus q. So we have got the value for theta, isn't it? So now, first of all, we had assumed sine inverse root over x minus q by p minus q is equal to theta. And we just now proved that theta is equal to cos inverse root over p minus x upon p minus q. Again, we now proved that theta is equal to cot inverse root over p minus x upon x minus q. That means we can equate all these three, isn't it? That means you can write, therefore, first one is sine inverse root over x minus q upon p minus q. It was assumed as theta, and now theta is equal to cos inverse. So you can equate this sine inverse with this cos inverse, which is equal to cos inverse root over what is here? P minus x upon p minus q. P minus x upon p minus q. Again, which is equal to? Again, theta is equal to. You can equate this one also. That is, which is equal to cot inverse root over p minus x upon x minus q. So we have proved this result, isn't it? Proved. That means all these three are equal, right? So we have proved this, question number 20. So this is very, very important question. You can revise it at home, okay? So we'll do the next question now. Now we will do question number 21. Here also, this one is prove that tan inverse cot x plus cot inverse tan x is equal to pi minus 2x. Okay. So let us prove LHS is equal to RHS. So LHS is equal to tan inverse within bracket cot x plus cot inverse within bracket it is tan x, right? So now let us prove right hand side, that is pi minus 2x from this left hand side, okay? So if it is tan inverse, you can convert this cot x into tan x, isn't it? You know this formula. Cot x is equal to tan 90 minus x, isn't it? Tan pi by 2 minus x. You have done it in class 10 also. There is also cot inverse tan x is there. If it is cot inverse, you should convert this tan x into cot x. How can you convert it? Similarly, what is tan x is equal to? This is cot pi by 2 minus x. So we can use this formula here, right? So is equal to tan inverse. Now what is cot x in terms of tan? It is tan, you cannot write 1 by tan x here, isn't it? Tan inverse 1 by tan x cannot be simplified. Here also you cannot write cot inverse 1 by cot x. But you should write cot x is equal to tan 90 minus x. But 90 degrees should be written in terms of radian, that is pi by 2. And again tan x is equal to cot pi by 2 minus x, right? So it is tan pi by 2 minus x plus cot inverse. This is your cot pi by 2 minus x. Is that clear? So tan x is equal to cot 90 minus x. That is pi by 2 minus x, right? So here, what is tan inverse tan x from x? But in this case, it is pi by 2 minus x plus. In this case also, what is cot inverse cot pi by 2 minus x? It is also pi by 2 minus x, which is equal to, actually this is pi by 2 plus pi by 2. What is it? Pi by 2 plus pi by 2 is 2 pi by 2. 2 gets cancelled, you will get pi. And what is minus x minus x? It is minus 2x. So which is equal to right hand side. So it is proved. Okay. So now I will give you the homework. So you can do some question at home. Okay. You can try it. Now, these are your homework. You have to prove that this is from page number 98. Okay. This question number 15 is from page number 97 and this question number 16 is from page number 98. This is from page number 97, right? This is from page number 97 and this is from page number 98. That is, this question number 15 is from page 97 and this question number 16 is from page 98. Okay? So you have to prove it. You have to prove this number 15, LHS is equal to RHS. So I'll give you the hint. Sin inverse 2a upon 1 plus a square minus cos inverse 1 minus b square upon 1 plus b square is 2 tan inverse a minus b upon 1 plus ab. So if you know the formula on the left hand side, directly you can write it. Sin inverse 2a upon 1 plus a square is 2 tan inverse a. Cos inverse 1 minus b square upon 1 plus b square is 2 tan inverse b. So you can take common there 2. So within bracket we have tan inverse a minus tan inverse b. So that you can use the formula to prove it. Okay? Or you may use, if you don't know the formula, you can put here, put here a is equal to tan theta. Then simplify it. Get the value of theta there. Here you can put b is equal to tan beta. If you put here a is equal to tan theta, you cannot put b is equal to tan theta there. You have to put b is equal to tan beta because these two are different variables, isn't it? This is a variable and this is b variable. Since these are different variables, you have to assume a is equal to tan theta here and b is equal to tan beta there, isn't it? So you can derive the formula and prove the required result. You can do it at home. Okay? And now number 16, you have to prove this left hand side is equal to 0. That is cot inverse xy plus 1 upon x minus y plus cot inverse yz plus 1 divided by y minus z plus cot inverse zx plus 1 divided by z minus x. So you can use a formula on the left hand side. What is that formula used? Formula that you should use here is cot inverse xy plus 1 divided by y minus x is equal to, what is the formula? It is cot inverse x minus cot inverse y. You can use the formula here. Okay? Cot inverse xy plus 1 divided by y minus x is equal to, what is the formula? Cot inverse x minus cot inverse y. You can use the formula in this case. So in this case xy plus 1, तर यहाँ के छ? यहाँ x को जग्गामा यहाँ y छ, y को जग्गामा यहाँ x छ. That means its formula will be cot inverse y minus cot inverse x. बुझ्यो? Cot inverse y minus cot inverse x. This one, you can use this formula. Instead of y, there is y. Instead of z, there is x. What is the formula? Cot inverse x. That means cot inverse z minus cot inverse y. This is cot inverse x minus cot inverse z. Is that clear? So you can use this formula in order to prove this number 16, that is left hand side is equal to 0. Okay? So you can revise all the problems that we have done today. Okay? And you can do other problems also. The previous problem also we did, isn't it? That is previous problems, that is you can revise it. त अगाडि जति पनि हामीले प्रब्लमहरु गरिसकेका थियौं त्योहरु पनि रिभिजन गर्नु अनि यो होमवर्कहरु गर सजिलो भइहाल्छ ठीक छ सो दिस मच इज फर टुडे ओके we'll do more problems in the next class.